Okay, I want to go over this argument and explain how to diagram it. I put this as an extra credit problem last week, so let me go over it. This is not an easy argument to diagram. Very few people get this right the first time to diagram it. So let's look at how to diagram it. There are seven statements. I'll read it. Powerful new particle accelerators are important in high energy physics, and they are worth their cost because 3, they will allow scientists to produce and capture significant quantities of Z particles. 4, Z particles result from the collision of positrons and electrons. And 5, particle accelerators are needed to achieve significant numbers of these collisions. 6, Z particles are thought to be the bearers of the weak nuclear force. And 7, learning the nature of this force may lead to the development of entirely new sources of energy. So the first thing we want to do is, let's just look. You look through, you read it, and you want to find out what's the conclusion. First of all, to diagram an argument, you got to figure out what the big point is. What's it trying to prove? Well, the very first sentence, usually it will tell you at the beginning or the end. Very rarely is it going to be put in the middle. It tells you at the very beginning what the big point is. Powerful new particle accelerators are important in high energy physics, and they are worth their cost. Okay, that's basically. So I'll put 1 and 2 will be what we're trying to prove. So I'll just put 1/2. You know, that's, I think, basically it's two statements are basically what this is trying to prove. It's trying to prove powerful new accelerators are important in high energy physics, and they are worth their cost. So I guess you might, if you wanted to, you could probably go to they're worth their cost because they are important in high energy physics. So that would work too. In this case here, it says and, so that's why I put it this way. But I mean, sometimes there's different ways to diagram an argument. It depends on the emphasis. You could go 2 because of 1. They, referring to new particle accelerators, are worth their cost. Imagine that citizens are voting on this issue, whether to have their tax dollars spent to develop these new particle accelerators. So the argument might be then you say, they're worth their cost. I mean, you should vote for the tax increase. Why? Well, because they're important in high energy physics. So that would work too. 2 because of 1. But you could also do 1/2. I'll just do 1/2. Just because that you could also construe it that way. Basically, the person just making the point that it's a double point. They're important in high energy physics, and they're worth their cost. Why? Well, so that's a way to figure out why. So why should we believe that they are so important for in physics and they're worth their cost? Okay, well, 3 says because. I mean, this is a premise indicator, so you want to look at for these type of words. This tells you that statement 3 follows from 1 and 2. So 1 and 2 because of 3. Now, there may be something added onto 3, but at least 3 is going to be one of the reasons. They, referring to new particle accelerators, will allow scientists to produce and capture significant quantities of Z particles. That is one reason why they're so important for physics. It's part of one reason. I mean, there's other reasons. Going to obviously have to add it on to that because I mean, most people don't. So what? What's so great about Z particles? They will allow scientists to produce and capture Z particles. So what? So that's what we have to understand. So what? Well, if you look on 4, it doesn't tell you anything about so what. It just tells you where Z particles come from and how to produce them. So, and 5 doesn't say anything about, is not going to add anything to this. Particle accelerators are needed to achieve significant numbers of these collisions. So 4 and 5 aren't going to help to explain why 3 is important. 4 and 5 just tell you about how you're going to get this, where it's going to come from. But look at 6. Z particles are thought to be the bearers of the of the weak nuclear force. So we'll put that in there. We'll add that on there. So 3 just said these accelerators will allow us to capture Z particles. 6, actually it should be a 6. 6 says that Z particles are thought to be the bearer of the weak nuclear force, but that doesn't. So what? I mean, what's so great about the weak nuclear force? But 7 is very important. 7 tells you why 3 and 6 are important. That's the key. 3 plus 6 plus 7. If you take all those together, that is a reason to believe that taxpayers should put their money into developing. They're worth their cost. They are important for high energy physics. Look at 3 says these new particle accelerators are going to allow us to capture Z particles. And okay, but Z particles are the bearers of the weak nuclear force, plus learning about this weak nuclear force may lead to the development of entirely new sources of energy. So now we're going to get new sources of energy, and everyone knows that that's good. I mean, so when you invest in these particle accelerators, it's ultimately why it's important, why it's worth its cost is because the accelerators are going to allow allow scientists to capture Z particles, which are the bearers of the weak nuclear force. And knowing about that weak nuclear force is going to lead to the development of new sources of energy. 3 plus 6 plus 7 is a reason to believe that powerful new particle accelerators are important in high energy physics and they're worth their cost, meaning we should invest money in them. Okay, so 1 and 2 because of 3, 6, and 7. Well, okay, so what do we do with 4 and 5? Okay, because we still have to do 4 and 5. 4 says, so the one reason I think this is a little confusing because the 6 and the 7 are separated from the 3. So, because usually you want to kind of keep things together. It's easier to kind of understand that way. When you separate things, then it can be confusing. So that's why you need to carefully read. Analyzing arguments are very important because you have to go slowly and you have to look. You can't just, speed read it. You have to think about it. So it involves critical thinking. Diagramming arguments involve basically what diagramming an argument says. It shows if you can diagram an argument, what it means is you have good analytical abilities. You can understand the reasoning behind an argument. And it's not that easy. Some people can do it very well, some cannot. When you apply to law school, believe me, one of the LSAT tests, one of the things on that test, there's going to be stuff like this. They want to test your analytical ability. Can you analyze an argument? Can you pick out the conclusion? Can you understand, how the premises lead down to that conclusion, how everything is organized. It's not that easy, and it takes a little, but it's not that difficult either. But a lot of people can't do it. It takes work. Some people can do it very quickly. Others, whatever it takes. I mean, you have to put the time into it. But once you can do it, once you can do one argument, analyze a good complicated argument, you can analyze anyone, because once you can do one, you apply the same principles. In this argument here, because is the only premise indicator. Let's see if there's any other indicators, conclusion indicators. Z particles are thought to be in. No, there's only one. There's only one. There's no like a therefore in here. That would be a conclusion indicator. Here's a premise indicator. But let's look at 4 and 5. Z particles result from the collision of positrons and electrons. Okay, so that's Z particle. Where do we get Z particles from? They come from the collision of positrons and electrons. And particle accelerators are needed to achieve significant numbers of these collisions. So basically what 4 and 5 are saying is that Z particles come from the collision of positrons and electrons, and you can't get these without particle accelerators. So if you want to get Z particles, you're going to need particle accelerators. That's very important, because look at 3 says powerful new particle accelerators are important, and we should invest our money. Why? Because these particle accelerators, will allow scientists to produce and capture significant quantities of Z particles. Z particles tell us about the weak nuclear force, and that will lead to new sources of energy. But let's say you say, I need to be convinced. I don't believe 3. You need to convince me. You need to give me some proof, evidence that 3 is true. And that's where 4 and 5 come in. 4 and 5 are evidence. Remember quartile, Q-U-E-R-T-O-L, quartile. The E, provide evidence. E stands for enough evidence. So 4 and 5 are going to provide evidence for 3. If you ask the question, why should I believe that 3 is true, that powerful new accelerators will allow scientists to produce and capture significant quantities of Z particles, why should I believe that that's true? Here's your answer, 4 and 5. It's true because if Z particles result from the collision of positrons and electrons, and you cannot get these positrons and electrons without these powerful accelerators. These accelerators will allow scientists to produce and capture significant quantities of Z particles, because you can't get Z particles without them. Because these Z particles are from the collision of positrons and electrons, and you can't get those without the new accelerators. So 4 and 5 is the reason for 3. So 1 and 2, because of 3 plus 6, don't forget the plus. These are dependent premises. If you leave the plus out, it will not work. 3 is not a reason for 1 and 2. And 6 is not a reason for 1 and 2. And 7 is not a reason for 1 and 2. But you put all those together, and they are a reason for 1 and 2. And the same thing up here. These are dependent. When you put a plus between 2 numbers, they're dependent. It means you need both together. 4 and 5 is a reason for. Okay, this is for 3. This is the diagram of that extra credit problem I gave you. That's it. And you could get it. Everyone could get it if you put the time into it, and go slowly. It might take you 10 minutes, 15 minutes, but if you think through it, you'll get it. But you got to put the time into it.